Hi everyone, this is Applied Math for the Wood Tech program at Western Technical College, and today we're going to talk about common fractions. In your line of work, which will be hopefully building things someday, you're going to incorporate a lot of fractions because we usually don't have things that are exactly 3 feet, 7 inches. We do break our inches up into smaller pieces. So just to remind us of some things, a fraction, first of all, has what we call the top number. So I'm just going to write 3/4. That top number is referred to as the numerator, and the bottom number is referred to as the denominator. Hopefully I spelled this right. There are 2 types of fractions that we talk about, and one is called an improper fraction. Oops, I forgot the I. Squeeze it in there. And a proper fraction. And the difference between the two is a proper fraction is when that numerator is smaller than the denominator. So the numerator is smaller than the denominator. Excuse my misspelling. An improper fraction might look like something like that, where the numerator, that top number, is larger than the denominator. Or possibly exactly the same. This is still considered an improper fraction. And the reason they're called improper fractions is because they can be rewritten into a form that makes more sense. They can be turned into something we call a mixed number. And a mixed number will have a whole part and possibly a fraction with it. So I'll put whole and a fraction. So for example, this 7/3 we know is going to be larger than 1. And to turn it into this mixed number, we are going to take that numerator and divide it by that denominator. So I'm going to take 3 into 7, which does go 2 times. So it goes in there 2 whole times. And 2 times 3 is 6, and we subtract, and we get our remainder. So this tells me that 7/3, 7 divided by 3 is actually 2 whole pieces and 1/3 left over. I like to sometimes think of a fraction as 2 parts. The numerator kind of telling you how many you have, and the bottom number telling you the size. And you may remember way back in elementary school, you may have put like pieces together. So here we could have referred to this as 2 wholes and then 1/3 of another one. Okay, to see our 7/3, we can divide these 2 into whole pieces, divided into our third. So I have 1, 2, 3, 4, 5, 6, 7 pieces, each of them 1/3 of the whole. So again, to go from an improper fraction to a mixed number, we're going to be doing some dividing. We're going to take and see how many times does that bottom, that denominator, go into the numerator. In this case, it went 2 whole times. We had 1 left over, so we had 1 piece left over. There's our leftover. And that told me how big those pieces were. Now 4/4, if I do that dividing, 4 goes into 4 exactly 1 time, so I get 1 whole with no fractional parts left over. So to see that as in a picture, I'm going to take my whole, divide it into 4, because I want the 4s telling me how many pieces to divide it into, the bottom number. I have 1 whole, and here's my 1, 2, 3, 4 fourths. Okay. We can sometimes need to go from that mixed number to the improper fraction. So let's talk about that. So let's say I have 7 3/4, and I want to turn it to an improper fraction. Okay, for whatever reason. And there will be reasons we will do that. To do that, we're going to kind of go backwards. If you remember before, we did dividing, and then we had that remainder. So we're going to take our 7 wholes, think of our 7 whole pieces here. I'm not going to draw all 7. And we're going to chop them up into the pieces we want. Well, the bottom number tells me how many. So we've got these guys. We're going to chop them all up into 4. And I'd have 7 of these. So imagine 7. So 7 groups of 4. So we're going to take that 7 groups of 4, or 7 times 4. That would give me 28. So I have 28 fourths sitting here in my 7 wholes, but we also have 3/4 as well. So we're going to add those extra 3 pieces that would have been separate. So that would give me a total of 31/4. So again, we take that whole number times the denominator to tell me how many pieces we'd have in those wholes. We add on the extra, and we get that 31/4. This here number here is like 7 3/4. There's an operation that's going on between them. It really represents 7 wholes plus 3/4 of another one. So kind of imagine that plus sign sitting in there. Okay. So again, to go from mixed to improper, we multiply that whole number times that denominator, add the numerator, and make sure we keep that denominator the same, because that told us what size those pieces were. The last thing we're going to talk a little bit about is reducing fractions. Because sometimes we can have fractions that look or can be made simpler. So for example, 6/8. So 6/8. And if you look on a ruler, you could find 6/8 of that. But you can also rewrite this. And to reduce fractions, what we're going to do is look for numbers that both the top, the numerator, and the denominator have in common. So both the 6 and the 8 have a 2 in common. So what I'm going to do is divide that 2 out. So I'm going to take my 6 divided by 2 and get the 3, 8 divided by 2, and get my 4. And if I were looking on a ruler, which I'll show you here, my ruler. There's my ruler. Okay. This is broken up into really, really tiny pieces. My 6/8, if I can do this here, 1, 2, 3, 4, 5, 6 is right here. There's my 6/8. But if you look at broken into the fourths, it's 1, 2, 3, 4 as well. So you can kind of see the 3/4 and the 6/8 all in the same time. And if you wanted to pull out your rulers or your tape measures, you could probably practice a little bit with some of the more common fractions that you guys will be familiar with. All right. Sometimes, though, we have to get beyond just what's on our rulers. So, for example, let's say we have 27/63. I don't know. And this one might be a little harder to see. So some things I usually look for are some of the rules that we have for dividing. Dividing by 2 is we will see that they were both even numbers. There are some tricks for divided by 3, and there are some tricks for others. Some of them you might know. Divided by 10 must end in a 0. I can probably put that by and in 0. If you want to divide by 5, it's going to end in a 0 or a 5. And if it's going to be divisible by 2, it's going to be even. So here's just some pieces. Divisible by 3 and well as 9 have the same kind of rule, is we add the digits. Okay, so I'm going to add my 2 and my 7. That gives me 9. Take my 6 and my 3. That also gives me 9. If that sum is divisible by either the 3 or the 9, the original number was. So since this was 9 and this was 9, that tells me that I have a 9 in both of these. Okay, so I can take 27 divided by 9, and that is 3. 63 divided by 9 is 7. If you had not seen the 9, maybe you only saw the 3. Okay, so if I divide by 3, this one gives me 9. This gives me 21. Now you may see that there's still a 3 in both of these. Get 3 over 7. So again, we can eventually get there. Sometimes it's going to take us a little bit longer to get there, but sometimes we'll get there right away. And it really doesn't matter as long as we get there. Okay, I'm going to stop here just because that kind of ends a little beginning of our fractions, and we will see each other in the next video.